Okay, welcome back to the series, and let's start with our first lesson, the helicopter basics. So, this lesson will introduce the student to the basic components, systems, and instruments of the helicopter. But first of all, what is a helicopter? A helicopter is an aircraft that is lifted and propelled by one or more horizontal rotors, each rotor consisting of two or more rotor blades. Helicopters are classified as rotorcraft or rotary-wing aircraft to distinguish them from fixed-wing aircraft, because the helicopter derives its source of lift from the rotor blades rotating around the mast. But before learning how to fly your helicopter, it's absolutely essential to familiarize yourself with helicopter components and controls. The main rotor system produces the helicopter's primary lifting capability. There are two major sub-assemblies that make up the entire system. The first is the rotor assembly, also known as the rotor hub, and the second is the blades. The helicopter's drive shaft delivers critical engine power to the main rotor assembly. The assembly also turns a secondary gear set that drives a horizontal shaft, thereby turning the tail rotor. In effect, should the main drive shaft fail, the aircraft will stop producing motive force, causing an immediate emergency landing. Typical helicopter main drive shafts are produced from the highest strength material. The helicopter skids are the essential landing mechanism for the typical helicopter. This assembly is typically made of high-strength tubular steel with horizontal and vertical braces. Aside from the skids themselves, shoes are also attached at the vertical braces to allow the helicopter to slide effectively on rough surfaces. Should the shoe be damaged? Probably, but the good thing is that this sub-assembly can be removed and replaced without having to replace the entire skid assembly. The tail rotor manages and creates horizontal lift or the yaw control via the tail rotor pedals. And finally, for the stabilizer, it helps to stabilize the helicopter in flight. Here are some of the basic controls you will need to operate your helicopter. On the left side of your seat, you will find the collective lever mounted on the cabin floor. At the end of the collective, you will find the grip called a throttle. In front of your seat, you will find a stick known as the cyclic. And finally, there are two anti-torque pedals at your feet which control the tail rotor. The cyclic control, commonly called the cyclic stick or just cyclic, is similar in appearance on most helicopters to a control stick from a conventional aircraft. The cyclic is used to control the main rotor in order to change the helicopter's direction of movement. In hover, the cyclic controls the movement of the helicopter forward, backward, and laterally. The collective pitch control or collective lever is normally located on the left side of the pilot seat with an adjustable friction control to prevent inadvertent movement. The collective changes the pitch angle of all the main rotor blades collectively. Therefore, if a collective input is made, all the blades change equally, and as a result, the helicopter increases or decreases its total lift derived from the rotor. In level flight, this would cause a climb or a descent, while with the helicopter pitched forward and increases in total lift would produce an acceleration together with a given amount of ascent. Helicopter rotors are designed to operate in specific rotational speed. The throttle controls the power of the engine, which is connected to the rotor by transmission. The throttle settings must maintain enough engine power to keep the rotor speed within the limits where the rotor produces enough lift to fly. The end-light torque pedals are located in the same place as the rudder pedals in an airplane and serve a similar purpose actually. They control the direction that the nose of the aircraft points to, and applying the pedals in a given direction changes the tail rotor blade's pitch, increasing or reducing tail rotor thrust and making the nose yaw in the direction of the applied pedal.